Do I believe in UFOs or extraterrestrial visitors? I'm not authorized to answer that question. Where shall I begin? UFO. First, remember what the U stands for in UFO. Now, there's a fascinating frailty of the human mind that psychologists know all about, and it's called argument from ignorance. And this is how it goes. You ready? Somebody sees lights flashing in the sky. They've never seen it before. They don't understand what it is. They say, a UFO. The U stands for unidentified. So they say, I don't know what it is. It must be aliens from outer space visiting from another planet. Well, if you don't know what it is, that's where your conversation should stop. You don't then say, it must be anything. Okay? That's what argument from ignorance is. It's common. I'm not blaming anybody. Psychologists know all about it, and it may relate to our burning need to have to know stuff because we're uncomfortable, steeped in ignorance. You can't be a scientist if you're uncomfortable with ignorance, because we live at the boundary between what is known and unknown in the universe. Unlike what journalists write. You ever see journalists? Any journalists here? You go to journalists. You go to journalists. All articles about science discoveries begin. Scientists now have to go back to the drawing board. As though we're sitting up in our office, you know, masters of the universe. It's like, oops, somebody discovered something. No, we're always at the drawing board. If you're not at the drawing board, you're not making discoveries. You're something else. So, the public, it appears, seems to have this burning need to have an answer to what is unknown. And so you go from an abject statement of ignorance to an abject statement of certainty. So, that is operating within us. Let's start there. Second, we know, not only from research in psychology, but simple empirical evidence in the history of science, that the lowest form of evidence that exists in this world is eyewitness testimony. Which is scary because that's some of the highest form of evidence in the court of law. But we know from second grade. Where's my guy from second grade? Get up to the microphone for a minute. Grab the microphone. Grab the microphone. In your classes, have you done the famous experiment where you play telephone and you line up all your kids in class and one person starts with a story and then you hear it and you repeat it to the next person and the next person? Have you done that in class yet?
Yes.
You've done that experiment? Because what happens by the time you get to the last person and they retell the story? What happens?
It's like completely different.
It's completely different. Completely different, okay? Because the conveyance of information was relying on eyewitness testimony, which in that case is ear witness testimony. And so, thank you. So we know that. So he knows it. He's in second grade. All right. So, actually he should be in 12th grade as we've established. So now, it wouldn't matter if you saw a flying saucer. In science, even if you have something less controversial than a flying saucer, if you come into my lab and you say, you gotta believe me, I saw it, and you're one of my fellow scientists, I say, go back, go home. Go back until you have some other kind of evidence that's not just you saw it, okay? Because human perception system is rife with all ways of getting it wrong, okay? But we don't like thinking of ourselves that way. We have high opinions of our human biology when in fact we should not. I'll give you an example of how it reveals itself. We've all bought and enjoyed books called Optical Illusions, right? Well, we all love optical illusions, but that's not what they should call the book. They should call them brain failures, okay? Because that's what it is. It is a complete failure of human perception, all right? All it takes is a few sketches that are cleverly done. Your brain can't figure it out, all right? So, we are poor data-taking devices. That's why we have such a thing as science, because we have machines that don't care what side of the bed they woke up in the morning, don't care what they said to their spouse that day, doesn't care whether they had their morning caffeine. They'll get the data right, okay? So, maybe you did see visitors from another part of the galaxy. I need more than your eyewitness testimony. And in modern times, I need more than your photograph, which Photoshop probably has a UFO button today. Like, stick it in, right? So, on your computer. So, here's what you do. I'm not saying we haven't been visited. I'm saying the evidence thus far brought forth does not satisfy the standards of evidence that any scientist would require for any other claim that you're going to walk into the lab with. So here's what I recommend. Next time you're abducted, because I'm ready for this. I'm ready, okay? I get abducted, I'm ready, okay? So you're there, you're like on the slab, because they always do like the sex experiments on you, on the flying saucer. So there you are, and they're poking at you. Here's what you do. You ready? You tell the alien, you're gonna be alien for this, right? So you're poking me, all right? So then I say,
finally, I'm on this side of the equation.
okay, so I say, hey, look over there. And then he looks over there, you quickly like snatch something off the shelf, put it in a pocket, and then lay back. All right? Then you're done, you come back, you say, look what I got. Okay, I like stole the ashtray off the shelf of the flying saucer. And then you bring that to the lab. And it's not about eyewitness testimony at that point, because you'll have something of alien manufacture. And anything you pull off of a flying saucer that crossed the galaxy is gonna be interesting, okay? Because even objects within our own culture. I got this device here, okay, the iPhone. 10 years ago, they would have resurrected the witch burning laws had you pulled this thing out, okay? And that's in our own culture. Our own culture produced this over a 10-year span. So if there's some technology that crossed the galaxy, that's gonna be some serious stuff to look at in the lab. Then we can have the conversation. Until then, I can't, I'm sorry. Go ahead, keep trying to find them. I'm not gonna stop you. But get ready for that time you are abducted, because I'm gonna be looking for your evidence when that happens. And last point on that is, there are people who look up all the time. Like, for example, the community of amateur astronomers in the world. I was an amateur astronomer. We come out of a building, we look up. Doesn't matter, we're looking up. UFO sightings are not higher among amateur astronomers than they are in the general public. In fact, they're lower. You say, well, why is that so? Well, because we know what the hell we're looking at. We know. Do you know? I don't. Because we study this stuff. Do you know there was a UFO sighting reported by a police officer, because we think that because you have a badge or you're a pilot or you're whatever, that your testimony is somehow better than that of an average person. It's all bad because we're human, okay? So there was a police officer who was tracking a UFO that was swaying back and forth in the sky, okay? Reported on the hot, they're in one of the, what do you call the car? The squad car, chasing a UFO, and the UFO's moving back and forth like this, okay? Later it turned out the cop car was chasing Venus, and he was driving on a curved road. But was so distracted by Venus, he thought Venus was the one moving, and he wasn't even thinking that he was doing this. So, I have seen things which, without my background in meteorology and astronomy and looking up, I would have reported to the police department. I would have. Like orographic clouds that form above huge mountains that are circular. And they're above a tall mountain, which means wherever you are, the sun can set for you before it has set for the cloud, darkening the skies, yet the cloud is now illuminated by sunset colors, which are what? Red, yellow, orange, and it's circular. There have been reports of hovering circular UFOs with light beams on them because people are looking at this cloud formation on top of mountains. So, maybe we have been visited by aliens. Maybe they've even landed. But why do they land in like the farmer's yard and not like Times Square, all right? And then I worried, like maybe they had landed in Times Square, but nobody took notice. You know, because that's the really big problem there. And so there's a huge answer to it because there's a lot built into it. So here's another concern I had. Oh, you said about movies earlier? Remember Close Encounters of the Third Kind?
Absolutely.
You remember that? And the aliens come in this big flying saucer?
Sure.
Okay, and what do? We turn on runway lights for it. I'm thinking, flying saucers don't need runway lights. They're flying saucers, for goodness sake. If you put a bullseye or something.
You did need them when we landed on the moon.
Don't put runway lights for this thing. Then, when you go to Roswell and there's like crashed flying saucers, I'm thinking, if the alien came across the galaxy and couldn't land a damn spaceship, I don't want to meet the aliens. They're stupid aliens, all right? You at least land on Earth, for goodness sake. Don't tell me you came across the galaxy, you can't land on Earth. Go home. Bring me somebody who can, then I'll have the conversation. Anyhow, so those are my opinions on the subject. We got the Big Bang. That's been going for a while. Now, not everybody's happy with the Big Bang. You found this billboard. So apparently, God isn't happy with the Big Bang. I would have thought he'd be totally cool with it, but apparently not. I found this bumper sticker in New Mexico. The Big Bang Theory. God spoke, bang, it happens. This one is okay with the Big Bang, but that God did the Big Bang. So people are still trying to wrestle with this. Here's what we know. This is the entire universe in one slide. Quantum fluctuations, birth, an entire explosion, rapid expansion, we call it inflation. That's an idea that came about in the 1970s when there was inflation, severe inflation in our economy. So the word had a lot of currency back then. Now it's like you're inflating a tire, like what are you doing, you know? There is the baby picture of the universe. That's that sort of aqua surface there. That's sort of the imprint of what happened in the very earliest moments, writ in the background sky. There it is, the cosmic microwave background, a record of the earliest moments of the Big Bang. Then it takes a little time to make your first stars. We call it the dark ages. Stars are made, galaxies mature. We come up to the present day, 13.7 billion years later. And that telescope, we can't see the whole name, it's called WMAP, Wilkinson Microwave Anisotropy Probe. They clearly didn't want anyone to pronounce that or remember it. I would just call it the Big Bang Machine. That made this measurement. And so it's a pretty coherent picture that we have of the origin of the universe. And here's that map that the space probe shown. And so this is a record of the earliest moments of the universe. And it tells us what the universe was up to. And data agree, we're all pretty happy with this, and we're kind of moving on. If you look at the chemical ingredients of life itself, you remember from biology class, we're mostly water. And good old water is H2O. 2 hydrogens, 1 oxygen. And if you could look at the sort of the element budget of life, hydrogen is number 1, as expressed in the water molecule. The number 2 in the human body is oxygen, turns out. Number 3 in the human body is carbon. 4 is nitrogen. 5, you find on all lists, is other. Okay, now if you go to the universe, that's the O on the periodic table. You didn't know that? That's not for oxygen, it's for other. So you go into the universe, number 1 ingredient in the universe is hydrogen. That was true in life. Number 2 ingredient in the universe is helium. We don't have that one.
It doesn't like anybody.
Now, how come? Well, because helium is chemically inert. You can't do anything with it even if you wanted. You can inhale it, okay? And sound like Mickey Mouse, yes. Next in the universe is oxygen. Next, carbon. Next, other. Thank you, in the third row there. So, actually that was the second row. They must be related to the second row here. We are 1-for-1 matchup with the most abundant ingredients in the universe. Of these, carbon is the most chemically fertile element in the entire periodic table. You can make more kinds of molecules with carbon than all other molecules combined. So, if you were going to experiment through the forces of nature with complex chemistry, and you had to pick an element to base it on, carbon is your man. Or your woman, however that goes. Okay, so what I'm saying is, given what carbon is capable of doing, perhaps we shouldn't be so surprised that there's life, because we are carbon-based life. We're just another one of the things carbon has rolled up its sleeve. Maybe life is inevitable, given the abundance of carbon and oxygen and nitrogen and hydrogen in the universe. Try to invert that view. Otherwise, you're left thinking, hey, we're special. You know I would give you right to say you're special? If life on Earth were made of an isotope of bismuth. That stuff is nowhere in the cosmos, and then we're made of it, we're special. Okay? But if we're the most common ingredients of the matter that we know and love, you don't have an argument. And with regard to cell phone use, there's a very important fact of science, and that is the act of measurement. It's a fascinating thing, measurement, because you can never measure anything precisely. That is, with unlimited precision. You can only measure it with the uncertainties of your measuring device. And all you can do in the lab is try to constrain how uncertain that measurement is, but at some level it will always be uncertain. And here's what happens. If you're trying to measure a phenomenon that does not exist, the variations in your measurement will occasionally give you a positive signal, as well as a negative signal. If that positive signal is the idea that maybe A causes B, in this case, cell phones cause cancer, a paper gets written about that result, and then people get concerned that cell phones might cause cancer or power lines might cause cancer. This goes way back. And so, in fact, if you look at the full spate of these studies, even those that they thought not to publish because it was not a positive effect, there's some cases where, in fact, there's less cancer. And so these are the phenomenon of a no result. When you actually have A causing B, the signal is huge. It is huge and it's repeatable in time and in place. With cell phones, that repeatable signal is yet to emerge from the total experiments that are done on it. That being said, if you're worried, almost every cell phone they have the cell phones on your hip and you've got an earpiece. So just do that if you're worried. But otherwise, I can either say the jury is still out or the experimental results are consistent with no effect at all. I don't want the religious person in the lab telling me that God is responsible for what it is they cannot discover. Because look at the hubris of that. You're in the lab and you say, I don't know how this works. And not only that, no one alive on earth knows how this works. And not only that, no one who will ever be born will know how this works. That's kind of audacious when you think about it. And then you put it down and go on to the next problem. If this problem is a cure for Alzheimer's or cancer or whatever else, I don't want them in the science classroom. And so the issue is simply about progress and discovery. And in my recent forays into Washington, well, I've been closer to a community of Republicans than I've ever been in my life, because I grew up in New York City. And in New York City, I think that person is Republican back there. You see? No, not that one, the one behind that person. Yeah, that's a Republican. There's another one. That's in New York. So you grow up this way, and I get sort of baptized into a Republican administration. I had 2 consecutive appointments in the Bush administration, one on the aerospace industry and one on space exploration. NASA's future, basically. And I realized something, spending that much time in the community of powerful Republicans, that Republicans, above all else, do not want to die poor. So, there's a limit to how far this will go. And I bet most people in this room, even those assembled at this table, were highly concerned about the Dover trial, wondering how that would turn. And I looked at that and I said, I'm not worried, because it's a Republican judge. And in the end, if you put people who are not making discoveries in the science classroom, that is the end of the foundation of your future economy. And so I had a little more confidence than others did because of this sensitivity to the money aspect of it. But we all know tomorrow's economies will be founded on innovations in science and technology, and of course that gets cut short if we lose our civilization, as what happened in Islam in 1100. And the last thought I'll leave you with, which concerns me greatly, if you do the math, okay? You know, just look, you look at all the Nobel Prize winners there ever were, some even in this room, and ask how many were Muslim. And it's like one, maybe two, okay? I think a second one was in economics. And the one we referred to was described earlier, the co-winner of the Nobel Prize with Professor Weinberg, Abdus Salam. And he's not Middle Eastern Muslim, he's Pakistani Muslim. Okay? Now, how many Nobel Prizes are won by Jews? It's like the fourth of the Nobel Prizes. Okay? Some high fraction of the total. And then you look, how many Muslims are there in the world? It's like 1 billion Muslims. How many Jews? 15 million tops. Okay? So you could ratio these numbers. Had Islam not collapsed in its intellectual standing in the year 1100, and you just do the ratios, they would have every single Nobel Prize today. So the fact that it's not only just a few, it's near zero, is deeply worrying. I'm concerned about what brilliance may have expressed itself and did not in that community over the past 1,000 years. That the ingredients, if you had asked your chemistry teacher 50 years ago, once you looked at that mysterious chart of boxes that sat in front of your class, the periodic table of elements, where did those elements come from? The chemistry teacher would actually not have an answer for you. They'll say, well, we dig them out of the earth. That's not where they come from. It took modern astrophysics to determine the origin of the chemical elements. We observe stars. We know what goes on in their center. They explode, laying bare their contents. And what we have discovered is that the elements of the periodic table, that which we are made of, derive from the actions of stars that have manufactured the elements, exploded, scattered their enriched guts across the galaxy, contaminating or enriching gas clouds that then form a next generation of stars populated by planets and possibly life. And so, when you look at the ingredients of the universe, the number one ingredient is hydrogen. Next is helium. Next is hydrogen, helium, oxygen, carbon, nitrogen. Those are the top ingredients in the universe. So you say, well, okay, that's kind of cool. Well, and you look at Earth, because we like thinking of ourselves as special, we say, oh, we're special. Well, what are we made of? Well, what's the number one sort of molecule in the body? It's water. It's water. Well, what's water made of? H2O, hydrogen and oxygen. Hydrogen and oxygen. In fact, if you rank the elements in the human body, with the exception of helium, which is chemically inert, useless to you for any reason other than just to inhale it and sound like Mickey Mouse, you can't die from helium unless that's all you breathe. Number one in the human body is hydrogen. Matches the universe. Number two is oxygen. Matches the universe. Number three, carbon. Matches the universe. Number four, nitrogen. Matches the universe. And for each of us, the fifth element, other, is the same in both places. Okay? Other. So, we learned in the last 50 years that, of course, not only do we exist in this universe, it is the universe itself that exists within us. And had we been made of some rare isotope of bismuth, you would have arguments, hey, we're something special. But there are people who are upset by that fact, saying, well, that mean we're not special? Well, I think it's special in another kind of way. Because when you look up at the night sky, it's no longer we're here and that's there. It's that we are part of that. And that association, for me, is actually quite enlightening and ennobling and enriching. In fact, it's almost spiritual, looking up at the night sky and finding a sense of belonging, given what we've learned about the night sky. And so now we have ourselves. Now, are we alone in the universe? We're made of the most common ingredients there are. And our chemistry is based on carbon. Carbon is the most chemically active ingredient in the entire periodic table. If you were to find a chemistry on which to base something really complex called life, you would base it on carbon. Carbon is like the fourth most abundant ingredient in the universe. Isn't that rare? You can make more molecules out of carbon than you can all other kinds of molecules combined. So if we ask ourselves, are we alone in the universe? It would be, in spite of my diatribe about UFOs, I tell you in the same breath that it would be inexcusably egocentric to suggest that we are alone in the cosmos. The chemistry is too rich to declare that. The universe, too vast. There are more stars in the universe than grains of sand in all the beaches of the world. There are more stars in the universe than all the sounds and words ever uttered by all humans who have ever lived. To say we're alone in the universe. No, we haven't found life outside of Earth yet. We're looking, haven't looked very far yet. Galaxies this big, we looked about that far. But we're looking. And how about life on Earth? How is it hard to form? Just because we don't know how to do it in the lab doesn't mean nature had problems. So it may be, given that information, that given the right ingredients, which are everywhere, life may be inevitable, an inevitable consequence of complex chemistry. If that's the case, we look around our own solar system, we look at Mars. All the evidence suggests that Mars was once a wet, fertile place, an oasis. There are dried riverbeds and floodplains and river deltas and meandering rivers. It's all bone dry now. Something bad happened on Mars. Some knobs got turned in its environment that left it the way it is right now. Some bad knobs got turned on Venus too. Runaway greenhouse effect. You saw the clip on that. 900 degrees Fahrenheit on Venus. Some knobs got turned there too. People say, why spend money up there when we spend it? Because up there we might learn about down here, okay? I don't want a runaway greenhouse effect here. Venus is the best example in the solar system of a planet gone bad. Let's learn about that first. So, it turns out we learned that asteroid impacts, when they hit, can cast rocks in the surrounding areas into space with escape velocity, so they never come back to the planet from which it was launched. If Mars was wet and fertile before Earth was, as all evidence suggests, and if Mars had life before Earth had life, it is possible for there to have been bacterial stowaways in the nooks and crannies of the rocks that were cast into space. There's some hardy bacteria that we already know exists on Earth. Survives extreme temperatures, pressures, freeze-dried, reconstituted, radiation. The hostile environment of space would be nothing to some of these bacteria. It may be that life on Earth was seeded by bacterial stowaways on rocks that were cast free from Mars. This is a plausible scenario that's called panspermia, the transference of life from one planet to the next. If that's the case, that makes all of us descendants of Martians. I want to alert you in advance. Now, let me give you a disturbing thought. A fascinatingly disturbing thought, and we'll leave you on that note. If you look at our closest genetic relative to human beings, it would be the chimpanzee. We share like 98+% identical DNA. We are smarter than a chimpanzee. So let's invent a measure of intelligence that make humans unique. Let's say intelligence is your ability to like compose poetry, symphonies, do art, math, and science, let's say, okay? Let's make that as the arbitrary definition of intelligence for the moment. Chimps can't do any of that. Yet we share 98, 99% identical DNA, okay? The most brilliant chimp there ever was maybe can do a little bit of sign language. Well, our toddlers can do that. Toddlers. So here's what concerns me deeply. Deeply. Everything that we are that distinguishes us from chimps emerges from that 1% difference in DNA. It has to, because that's the difference. The Hubble telescope, these grand, that's in that 1%. Maybe everything that we are that is not the chimp is not as smart compared to the chimp as we tell ourselves it is. Maybe the difference between constructing and launching a Hubble telescope and a chimp combining two finger motions as sign language, maybe that difference is not all that great. We tell ourselves it is, just the same way we label our books optical illusions. We tell ourselves it's a lot. Maybe it's almost nothing. How would we decide that? Imagine another life form that's 1% different from us in the direction that we are different from the chimp. Think about that. We got 1% difference and we're building the Hubble telescope. Go another 1%. What are we to they? We would be drooling, blithering idiots in their presence. That's what we would be. They would take Stephen Hawking and roll him in front of their primate researchers and say, well, this one is like the most brilliant among them because he can do sort of astrophysics in his head. Oh, isn't that cute? Little Johnny can do that too. Oh, that's so nice. Oh, in fact, Johnny just did that. Let me get it. It's on the refrigerator door. Here he is. He did it in his elementary school class. Think about how smart they would be. Quantum mechanics would be intuitive to their toddlers. Whole symphonies would be written by their children, and like I said, just put up on the refrigerator door the way our pasta collages are on our refrigerator doors. So the notion that we're going to find some intelligent life and have a conversation with it? When was the last time you stopped to have a conversation with a worm? Or a bird? Oh, well, you might have had a conversation, but I don't think you expected an answer, all right? So, we don't have conversations with any other species on Earth with whom we have DNA in common. To believe that some intelligent other species is going to be interested in us enough to have a conversation? They'll look at our Hubble telescope and say, oh, isn't that quaint? Look at what they're doing. So I lay awake at nights wondering whether simply we as a species are simply too stupid to figure out the universe that we're investigating. And maybe we need some other species, 1% smarter than we are, for which string theory would be intuitive, for which all the greatest mysteries of the universe, from dark matter, dark energy, the origins of life, and all the frontiers of our thought would be something that they would just self-intuit. I'm jealous of that possibility because I want to be around for those discoveries. Thank you all. If NASA weren't around, what would happen to our universe? Well, I can tell you this. If NASA weren't here, we would know a lot less about the universe. And we would be intellectually impoverished by that fact. Because I enjoy knowing where we are, where we came from, and where we're going. And those questions are answered from space. To know how Earth got here, how the sun got here, what the future of Earth will be, what the future of our sun will be. Will we need to leave Earth and find another planet? All of that comes to us from the discoveries of a space program. Much of those discoveries have come from NASA. So it's not that the universe would be different if NASA never existed. It's that we would be different in a way that I don't even want to think about.
So we wouldn't know a single thing about the universe.
Yeah, we wouldn't know a single thing about the universe. We'd just be rummaging on Earth's surface thinking that our solutions to all our problems come from looking down rather than from looking up. You know, I'd be embarrassed to show an alien that we kill each other to extract energy sources beneath the sands when the universe is full of limitless amounts of starlight. And oh, by the way, someone once, reading my tweets, someone asked, when I compose my tweets, am I high? You know, so it was weird. One time I was distracted by a doily, and I was concerned that not enough people paused to reflect on the beauty and majesty of a doily. Right? Just think about what a doily is, and it's just to sit under your cup. And so I got to tweet something about that now. Hang on a sec. Let me do this. Just be a moment. That's right, because I'd already started. So my response will be to those who ask, am I high? Knowing that the sky sits above the entire Earth, that should tell you that the study of the universe is itself a state of natural high. Tweet. Okay. Napoleon, if you visited his library, it's not just sort of books of world history and battles, it's engineering books, it's physics books. This man wanted to know where his cannonballs would land, all right? He was much more than just sort of a lucky general. He was into the physics, the engineering, and the material science of war. And so he immediately summoned up the 5-volume production of Laplace, read it through, cover to cover, called in Laplace, and said, sir, I have the exact quote here. Hang on. Napoleon asked him what role God played in the construction and regulation of the heavens. This is kind of like, that's what Newton would ask, right? Laplace replies, sir, I had no need for that hypothesis. And so what concerns me now is, even if you're as brilliant as Newton, you reach a point where you start basking in the majesty of God, and then your discovery stops. It just stops. You're kind of no good anymore for advancing that frontier, waiting for somebody else to come behind you who doesn't have God on the brain and who says, that's a really cool problem, I want to solve it. They come in and solve it. But look at the time delay. This was a 100-year time delay. And the math that's in perturbation theory is like crumbs for Newton. He could have come up with that. The guy invented calculus just on a dare, practically. When someone asked him, Ike, how come planets orbit in ellipses and not some other shape? And he couldn't answer that. He goes home for 2 months, comes back, out comes integral differential calculus, because he needed that to answer that question. And so this is the kind of mind we were dealing with Newton. He could have gone there, but he didn't. He didn't. His religiosity stopped him. And so we're left with the realization, of course, that intelligent design, while real in the history of science, while real in the presence of sort of philosophical drivers, is nonetheless a philosophy of ignorance. And so, regardless of what our political agenda is, all you have to say is, science is a philosophy of discovery, intelligent design is a philosophy of ignorance. That's all. I don't need to see whether, have you discovered anything lately? If not, get out of the science classroom. But I'm not going to say, don't teach this, because it's real, it happened. So I don't want people to sweep it under the rug, because if you do, you're neglecting something fundamental that's going on in people's minds when they confront things they don't understand. And it happens to the greatest of the minds, as it happens to everyone else, many, if not most other people in the public. Yeah, that's better music here. The face on Mars. Dun, 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 dun. So everybody got excited. Well, sorry, not everybody. Those people who were sure that life on Mars had a simian face, okay? I mean, think about it. Most life on Earth does not have a simian face. Most life on Earth doesn't have a face, all right? So life with which we have DNA in common. All life on Earth has DNA in common. Now you're going to go to another planet and it has a face. The only things on Earth that have faces are like vertebrates have faces. That's a vertebrate face. So you want to say that there are vertebrates on Mars and they're simian in their biology. Well, there's only one thing that looks like a face, no matter the camera angle. And what is that? A face, yes. So we go back at another time, and this is what it is at another time with higher resolution. It looks less like a face. You can kind of see how it might have been. Now, all the Mars fanatics said, oh, the Martians figured out we were looking at them, and they quickly covered up the monument. Then you go back again, and it's like even less like a face. So the Martians have continued to cover this up, apparently. So more on that later. But in fact, I do have the first evidence from the rovers. This photo, in fact, has been kept from the public till I have special connections to NASA, as you heard in the introduction. So this one was the first image taken by the rovers, and it's been suppressed by NASA ever since. Right. So I thought I'd share it with you guys because, like, you know, you're my people tonight here. By the way, if you're looking on Mars for faces, why not look for other things that are familiar? You know, you only see that as a face because we have a face. And familiar things are what you pick out, even if they're not really there, right? When you look up in the clouds, you don't say, oh, I see a lobster. No. Has anyone ever said they see a lobster? No, you say, I see Abe Lincoln or George Washington. You're looking at sort of familiar iconography of our culture. And so let's find some more familiar iconography in the Martian terrain. There's the Valentine crater. There you go. We got one of those. How about the smiley face crater, right? So if you look hard enough, you can find stuff and call it whatever you want. There is fundamentally no business case for private enterprise to advance a space frontier. When you advance a frontier, you are making mistakes that the capital markets choose not to value. You have to create patents to enable things that you don't know will work. Anytime you are the first person to do something on that scale, the history of human civilization has demonstrated that the only funding available to do that is via governments.
Yeah.
And so what then happens is the patents get issued, the government figures out how to do it, they make it sort of routine, but they're inefficient because it's the government. Then you cede it to private enterprise.
Can you give us an example?
Sure. The Dutch East India Trading Company. They were not the agency that found America from Europe. That was Columbus, funded by Queen Isabella. There was Magellan, also funded by Spain. They laid the groundwork to find out where to go. Does the Earth have an edge or not? Is it something worth doing? Then behind them, the Dutch East India Trading Company came to conduct business in a way safer than could have possibly have been economically justified had they been the first to do it. You look at the railroads that crossed the United States. Newt Gingrich mentioned that as entrepreneurs leading the way, but he neglected the fact that Lewis and Clark got there first on a major funded expedition under the Jefferson administration. So you lay out the land, you map the rivers, you map the terrain, then you've got an understanding of what the risks are for the capital markets to then value then they come in behind. So I see any participation of the private enterprise in space exploration, not the first ones to go to Mars, not even to go back to the moon, but to make our access to low Earth orbit the efficiently costed exercise that it really should have been at the beginning of the shuttle but was never realized.
And that is what they're doing.
Yeah,
Since you are our future, I want you to understand something and not forget it. Are you ready? Okay. Religions all over the world constitutes what we call belief systems. Okay? And your freedom to believe whatever you want is a right and even a privilege in a free society. That's a good thing. Consider, however, that if you believe something that's part of a religious philosophy, and someone else has a different religion that's a different religious philosophy, and you're not agreeing with one another, and there's another religion over here, and another over here, and they don't agree, you're still free to believe what you want. But what that tells you is that it is unstable to build a government on a belief system. What you want is objectively verifiable truths around which we can all agree. That's what you build your economic system on, your governance on. Once you have that, then you go forth to your mosques, and to your churches, and to your... Go forth and preach and believe whatever you want. But know the difference, as Galileo did, between how to go to heaven and how the heavens go. That's my answer to it. I'm going to appeal to you in a way that most people don't. I'm going to tell you things other people are not telling you. You get people who are space enthusiasts, let's go into space, it's our destiny, it's our next, great nations do it. And I look at history and I say, no, you don't know what you're talking about. Here's what we got to do. We've known since the Industrial Revolution and earlier that innovation in science and technology, yes, it'll help defend the nation. But when you're not at war, you know what else innovation in science and technology does? It is the engine of tomorrow's economy. The engine. When Einstein wrote down his equation for the stimulated emission of radiation, which is the foundation of the laser, was he thinking to himself, barcodes? This is innovation in science, the applications of his ideas into machines requires the clever engineer, creative investors, and dynamic CEOs turn it into product. Don't ever tell me, why are you studying this? How is it helping me? You know, I don't know how it's going to help you. I have no idea. Neither did Faraday. He just knew you would tax it. Neither did Einstein. Neither did anybody who made great discoveries about our understanding and our relationship to nature. CERN, this is where they have the famous Large Hadron Collider. This is like they're at the limits. It is the highest energy ever attained on Earth. And by the way, we would have done 3 times this energy had Congress not cut the funding for the superconducting supercollider that would have been built in Texas. That was cut back in the early 90s, right around just after peace broke out in Europe, by the way. Physicists are only really useful when we're at war, according to government funding patterns. So they're looking for the Higgs boson and anything else that shows up on the docket. The Higgs is a particle that gives mass to other particles. So it's kind of cool. Some people have called it the God particle, and including physicists. What are they doing over in China? Well, they're building the largest dam in the world, the Three Gorges Dam, and they have a burgeoning aerospace industry growing at 14% a year, 13% a year. The economy is growing at 10% a year. By the way, what's your interest rate you're getting on your savings account in your bank? 0.003. Okay. Did you get that over here? These get, well, if you go to this other bank, you get 0.005, you know? Yeah, so other countries, different things are happening. Do you know that in Russia, they want to actually send a mission to deflect Apophis? They actually are prepared to fund that. That picture that I drew and did my little dance, that's not funded. That's just ideas on a page. Russia actually wants to fund it. And they invited us to participate. And I said, well, sure. But then I thought about it. I was asked by the NewsHour, what are my top 10 news stories of the year? This was now end of 2009. What are my top 10? I said, I don't have 10 stories, I have 5. Okay, what are they? I said, one of them is Russia inviting us to join them to deflect Apophis. They said, why? I said, here's why. Why is Russia creating the spaceship that's going to deflect Apophis, which, if it hits, wipes out the west coast of the United States? Aren't we the ones who's supposed to fund that mission and then invite others to participate? Isn't this how it has always been before? So that was an important news story for me because that is the beginning of the end. That's where you think you're at the top and people start doing things on their own with or without you. And all of a sudden, you gradually fade to insignificance on the world stage. That was writing on the wall for me when we were not leading that mission. Let's keep going. How about Brazil? If I mention Brazil, what's the first thing you think of? Someone said, bikinis. The guys are saying, yeah, the tongue bikinis, yeah. Soccer, maybe? Okay. This is the American view of Brazil. I understand. It's completely understandable. However, it blinds you to the fact that they have a burgeoning aerospace industry. Do you know that most planes that you fly between regional cities is made and designed in Brazil? You're not thinking this because you're still distracted by bikinis. Brazil has the third largest aerospace industry in the world, employing 18,000 people. It's a $20 billion industry there, and they invented the first airplane that can fly on alcohol. Brazil. Now, we don't do that because we just drink our alcohol. See, that's how that happens. We don't even think to make a plane out of it. So notice the American bias that prevents us from recognizing the rest of the world rising up as we stand there flat-footed. So there's that, but there's also, here's a little bit of intelligent design here. Here's one that wants to accept the science, but then is like what's before the Big Bang. We don't quite know yet, so God was there. So of course, intelligent design is basically a God of the gaps. But my favorite way to end this then is to just reflect on, I want to do it just a fast tirade on stupid design, and this will be fast. Look at all the things that just want to kill us, okay? Most planet orbits are unstable, star formation is completely inefficient, most places in the universe will kill life instantly. Instantly. The people that say, oh, the forces of nature are just right for life. Excuse me. Just look at the volume of the universe where you can't live. You will die instantly. That's not what I call the Garden of Eden, all right? Galaxy orbits that we orbit once every couple 100 million years, you're bound to come close to a supernova that will wipe out your ozone layer and kill everybody on the surface who doesn't otherwise have dark skin because your high energy rays will give you skin cancer. We're on a collision course with the Andromeda Galaxy. Gone is this beautiful spiral that we have. And of course, we're on a one-way expanding universe as we wind down to oblivion, as the temperature of the universe asymptotically approaches absolute zero. That's the universe. Then Earth. Volcanoes, tsunami just killed, I think that number's higher, up 200,000 people, floods, tornadoes. None of this is any sign that there's a benevolent anything out there. And this 90% should be 99%, as was earlier noted. That's of all life that has ever lived is now extinct. Inner solar system is a shooting gallery, comets, asteroids, duck. And look how long it took to make multicellular life. Not from the beginning of the Earth. Life happened quickly, but not multicellular life. You needed your cyanobacteria to sort of crank on the oxygen, get the oxygen budget going. Then you could have that's sort of rocket fuel for multicellular creatures. But that took 3.5 billion years. That's hardly an efficient plan with us in mind. And in human beings, this is like the most tragic of them. I don't even include here the expression of free will where people want to kill each other. I'm talking about nature killing us without the help of human beings. Aggressive childhood leukemia, hemophilia, all of this. And we so much praise about the human eye, but anyone who's seen the full breadth of the electromagnetic spectrum will recognize how blind we are, okay? And part of that blindness means we can't see, we can't detect magnetic fields, ionizing radiation, radon. We are like sitting ducks for ionizing radiation. We have to eat constantly because we're warm-blooded. Crocodile eat a chicken a month, it's fine, okay? So we're always looking for food. These gases at the bottom, you can't smell them, taste them, you breathe them in, you're dead, okay? So I'm almost done. I'm sorry, I'm taking up your time here. And with the birth defects, most are unknown. Look at this. Others, it's like abuse and infection and stuff that human beings had something to do with. We have no idea. Oops, I pushed a button by accident, sorry. No idea. And, and birth defects are tragic. They're tragic, particularly if they happen to the family afflicted by it. And you just look at images of these aborted fetuses because of and most of these are stillborn, others are born with a heart outside the body. And so, this is all simply stupid design. And the problem is, if you look for what is intelligent, and yeah, you can find some things that are just really beautiful, and really, hey, that's a clever, the ball socket of the shoulder, and a lot of things you can point to, but then you stop looking at all the things that confound that revelation. And so if I came upon a frozen waterfall, and it just struck me for all its beauty, I would then turn over the rock and try to find a millipede, okay, or some kind of deadly newt, and then put that in context and realize, of course, the universe is not here for us, for any singular purpose. My favorite of all is, of course, you eat, breathe, eat, and drink through the same hole in your body, guaranteeing that some percent of us will choke to death every year, okay? Imagine if you had a separate hole for breathing and eating and talking. That would be just really cool, right? You could drink, breathe, and just talk, and you would never choke, all right? And it's not a hard request. Dolphins breathe and eat through different holes in their body. And that's a mammal. So this is like Santa Claus could bring this one. And this one, of course, my favorite of all, what's this going on between our legs, right? As you've heard, you've heard it. It's like an entertainment complex in the middle of a sewage system. No engineer would design that at all, ever. It's like the wrong juxtaposition of elements. I will end on that question. So, my energy for communicating science derives from the research that I do. The research, for me, is thrilling. The press reports the results of research, which for some projects can take many, many years. So if you want to become a scientist, you have to learn to love the questions just as much as the answer, because in fact, in some cases, you don't even get to an answer. You find out you're navigating the wrong path. So the people who say, oh, a graduate school is a pay, I can't, that is science. What you're doing as a graduate student is becoming a research scientist, And that's what you do. You work long hours, you're in the lab, you occasionally forego personal hygiene. You know, this is what that is, okay? I bet you Darwin and Newton did not smell very good, all right, is my guess, okay? Newton, while he is discovering calculus, all right, he's probably not saying, oh, I need a shower about now. No, he's pretty focused doing what he's doing, all right? And so that's where I derive my energy to share the passion. Now, I would do so no matter what. But there's a more important reason for doing it. And that is most pure research in the sciences that goes on in America today, that's not product-driven, goes on at universities, and the source of those monies are from public-based, tax-based funding agencies. So, collectively, we pay taxes to the country's portfolio of spending, some of which funds the science that's conducted by scientists. As a result, the science that's done, the scientist that conducts the research, is obligated to the public to share with them the fruits of their research. The public paid for it. And I submit to you that there was an era before that was taken seriously. There's an era where the scientist in the lab would say, the press is beneath me, they'll probably get my story wrong, I don't want to have anything to do with them, leave me alone. That happened only to the peril of the funding stream that went into those labs. And the first person to realize this in a big way was, in fact, Carl Sagan. Because what happened was, he would start bringing science to the public. He did it sort of first and best. And colleagues said, what, you're on the Tonight Show? You're a scientist, and you'd stoop to go on the Tonight? And he was criticized for this, criticized. Meanwhile, the scientific community saw their budgets rise. And so in astrophysics, we learned earlier than in other fields the value, the general value of bringing the fruits of our research to the public. And I can tell you that I don't know if I'm biased, probably I am, but maybe a little bit is not. I think Hubble images are pretty cool. I think these pictures I showed you tonight are kind of awesome. I think all of us, at some point, we look up and wonder what our place is in this universe. And a small fraction of the total population gets to actually call that their career. So at no time do I take it for granted that it is not only a privilege to study the universe, it's an honor to do so with the sanction of those who are taxpayers and who even come out and hear a lecture that I give. Thank you all again. Seattle.